How risky is risky?
I'm sorry. Okay, so as you can see here, here's the on Blackboard.
Eva is calling me. Interesting.
Okay.
Hello?
So I can hear you talking on the phone. Zach, you might want to mute your microphone there. All right, so so here we are in the semester, and you can see we've done all of this SNMP. That's kind of where you are. And look, all we have left is 3 things. So that should be, you know, that should give you an indication that we are really close to the end at this point, right? If you think about it, we have just 2 weeks, because we have this week, next week, and then the following week is just you guys doing your presentations. So I remind you, you have projects A and B, right? Project A is your Hadoop cluster. You'll have to demo that either through Zoom somehow, practice, you know, how you would do it, or you can record a video and we can see that video, I guess. You know, but you will, but it's gotta be a presentation. So we all have to be there to view it. And I get it's difficult. So we'll have, I still need to think about how that will be done. So any ideas, you know, let me know. And then also remember that on the Wednesday session would be the, you know, of 3 weeks from now, it would be pretty much the last day of the semester before finals. And so you will do your presentation on your system administration topic. Okay, remember everyone picked, you know, just a simple system administration topic. and you need to basically configure something or write a script, and then you'll need to demo what you did. So please, I still haven't received any ideas on this, so I need to see what you guys are working on, so please email me about it, okay? Make sure you're working on something. So that being said, that means we really just have 2 weeks left, okay? We have 2 weeks left of lecture, lab kinds of things. So I just wanted to give you, kind of, what we're gonna do so that you know. So this week, I have some slides. I really, as you know, the class is both system administration in Unix, but obviously when you're doing administration of Linux, like creating user accounts, well, there's like managerial things as well, right? So I've talked about those, like, you decide to be consistent, you decide to be, in your naming convention, things like that, which are not necessarily technical. You could call them managerial. So there's a few managerial issues that I need to cover, and I'm going to cover those today. They fit perfectly well in today's topic because really, like, the main idea of this week is web services, right? So anything that's web services, so you might want to think of it as HTML, something like that. All right, and so therefore that, within that topic, I'm going to talk about help desks, and a help desk could be online, or a ticketing system that could be online, and so on. And so, that's kind of, but there's going to be more managerial topics today than usual. And then obviously there's going to be the technical topic, which is, web services. So there will be a lab. What's great about this lab is that it integrates SNMP, right? So at the end of the day, we're building some kind of a website, and the website basically, we're building some kind of a website, and the website basically would have content. And in this case, it just so happens that our content will be SNMP related. Okay, so it'll tie in what you did last week of SNMP, which I think, should have been a pretty straightforward lab, with now developing. Now, this has a lot of code, but at the same time, it's an easy lab because I've given you pretty much all the code. All you have to do is kind of put it all together, right? So it's more of a, that's why it's more of a, Apache web services kind of a lab. So that's what we're gonna do this week. And I have the lecture slides here. You can see them. So that's what we will be doing. Next week, next Monday, I will do security and system administration. So that's a long topic on, security issues in system administration. And then of course we will look at something specific for the Unix operating system, which is, pretty standard firewall. So we've looked a lot, and we spent a lot of time on access control, because access control is just central to the whole of Unix. And so, but that itself is security, right? So, but now I'm gonna look, we're gonna look at, we'll do a lab basically that's more specific to, firewall. So that will be on Monday, and then on Wednesday next week, we're gonna do the SCAPI lab. The SCAPI lab is an easy lab, but it shows you just a library in Python that allows you to process network data, like PCAP data that you've been using in your Wireshark labs, for instance, okay? And so that, that pretty much tells you that you have 3 main labs left, right? This week's lab, and then 2 short labs next week on Monday and Wednesday. And then that's it. The semester's pretty much over. We've gone over all the topics. And then, then we will have so you submit your labs, you have two projects, A and B, the presentations, and then your final exam, and, you're done for the semester. Okay, so that's the plan. Okay, so now having said that, let's go into this link. So I want to explain a few things before I get into the slides so I don't forget. And I should say, before I continue, are there any questions about it?
For the projects, are we presenting it on Zoom? And do you mean like presenting it by like just implementation, or have a PowerPoint set up and then implementation after?
Yeah, it's a good question. So usually when we do this in the classroom, you basically do a PowerPoint to explain what it is. So let's say a group did email, like they do that's a nice project, for instance, they configured an email server, right? So they'll talk a little bit about an email server. So this is the email server that we use. This is the network setup and so on. And then after that, they say, oh, and now we're ready to talk about how we configured it, right? So they'll talk about the configuration, and then, and then finally they'll do the demo. Okay, so this is how it works. We've configured it. Now we're gonna, email something.
Okay.
Make sense, Yash?
Thank you. Yeah.
Yep. Any other questions, guys?
Professor, so for the second project, is the same principle then?
For project A and project B, Susanna?
Mhm.
Yes. So project A is, like I said, usually I call it like the practical. It's really configuring Hadoop takes a lot of Linux skill, right? And so that one is just basically, that one we're all doing the same. So you don't have to repeat pretty much what everyone has done. So that one could be more of a demo that you just say, okay, this is my cluster of let's say I have these two, machines, right, in the cluster. And then now this is the job that I'm going to run. And you run a job, like I said, word count, but you have to use the Hadoop framework itself.
Okay.
Yeah.
And for the second one?
You mean the topic that you picked?
Yes.
Well, that's kind of like what the example I just gave of the email, right? So, let's say you picked your topic is you wanted to learn about how to configure an email server or service in Unix, right? So then that one, because we don't know anything about it, you probably want to explain it a little bit more. So usually in the classroom, you would have had a few slides to talk about it, to talk about how it works, what it does. Obviously, we all know what email does, but still. And then after that, you talk about the configuration. This is how I configured it. But then you still have to do a demo. So you still have to say, okay, this is our service running in Unix. Here it is in our VM. And then now I'm going to send this email from point A to point B. Something like that. Does that answer your question, Susanna?
Yes.
Okay, great. Are there any other questions?
Is project B also group, or is it alone?
Yeah, it's a group. So
Okay.
they're both group. Work in the same groups if you will.
Okay.
Any other questions? All right, great questions. All right, please don't forget to send me your emails, just one per group on your topic, okay, of project A and project B, just so that I can basically make sure that what you're doing is, correct. It's 5% of your grade, remember? So for each project A and project B. So make sure you totaling 10% of your grade. So make sure you send me an email just so that we're both on, all on the same page. Okay. All right. Good. Great questions. Are there any other questions? All right. Okay. So then let's get to this week's topic. Like I said, I think, these last 3 labs are very good. They should be very eye-opening and interesting, but I don't think they're difficult at all. Right. So this one, the Apache, the Web SNMP, the one you're looking at right now, you guys should be looking at the Blackboard screen that I have right now. This lab is a little bit, the only part that's a little bit tricky, and I want to stress this, is the part of configuring Apache, the Apache part. So you'll see the lab is divided into 2 parts, configuring the Apache part and then configuring the Python code that you're writing to talk to SNMP. So configuring the Apache part, remember that the guidelines that I have in the document are not a tutorial, so they're just instructions. It might vary a little bit, okay? So you'll have to solve that to some extent, okay? Anyway, so this folder has a lot of files. It probably is the folder with the most files this semester, so it wins that prize. So basically what's in here is I put the 2 slides, right, that I'm gonna do today. Notice that I also have a Wireshark Scenario. So remember those? The same thing that we've done in the past applies here. it's just a reading assignment. All right. So remember, I want you guys to practice Wireshark a lot. So make sure you read this document, and then you know, you already should have the PCAP files. They're posted somewhere. And so do a reading assignment. So I'll create a separate Dropbox for this one, and then I'll have a Dropbox just for the SNMP. The instructions of that are here in Lab 12 instructions. And so I'm going to read this later, possibly even on Wednesday. So, you know, no rush there. But I do want to stress, just for those of you that like to start early with labs, that all these files that you see here are related to that project. That's all I want to say. So when you say, you know, you're going to need for that project SNMP manager code, right? And then SNMP web code. And then you're going to need SNMP pages.py, SNMP manager config. And then you're going to need details TPL and index TPL, okay? So all of those files, so it's basically because this is like, you know, you've taken 110, and some of you may already have taken 362 or classes in between. So you get that when you build a website, you need a lot of files in there, right? And so this is, you know, this is kind of an interesting way of exploring that, okay? So, oops, what happened? So I just wanted to stress that that's the approach that we're going to take. So going back then, this week we are discussing this topic, right? Basically, I should say it's really you know, this week a lot of miscellaneous topics, right? But some of them could fall within web services, because, you know, the web really, whenever you build an HTML, you know, a web application can be about anything related to system administration. So you can think of everything we're doing, you know, as linking everything. You know, a web application can even run scripts, right? So there's something called CGI that's a folder, and you put your scripts there, and then you can run them, or you can run or you can think of a web application. And this is really, so this is such an interesting project, because this actually brings in even cron. So, you know, basically you're going to query your SNMP data by putting some cron tabs, right? The cron entries in there, schedule, collecting the data, generating the data, and then also updating the website and so on. So there's a lot of integration of a lot of the topics in this one, okay? All right, so so let's get to it. So a lot of information, but at the end of the day, you might ask me, so what am I going to generate? What's going to be the output of this lab? Well, the output of this lab is, I'll put it in these terms. You're making, you know how in this lab we used the Cacti program from Linux, right? In this one, you're building your own Cacti. That's basically what it is. So all of that, you know, localhost, port 8080, where you make a connection to some web pages, you're building that. And you're building that thanks to the power of Apache Web Services, okay? So at the end of the day, that's what does the heavy lifting of Linux. And, you know, funny anecdote, or not funny, it's not funny at all, actually. But interesting is that, you know, when Unix first came out, you know, thanks to those guys, remember? Those guys that don't get enough credit, like the Bill Gates and the Steve Jobs. Can anyone tell me the name of that guy, one of the founders of Unix? Not Linux, not Linus, but Unix, I mean. Anyone? See, that's what I'm saying. You remember Steve Jobs, but you don't remember Dennis Ritchie. And, you know, he built Unix, right? He was, you know, one of the originators. And from there, you know, this amazing tool, you know, I honestly think is, you know, you guys should think of Unix or Linux whenever you know, go to work or anything. It's like a tool that you have. It's not that you learn how to manage that operating system and, oh my, I have to deal with it. But it should be that it's not just a server that's there. It's a tool that you have. It is your tool that you can, you know, you have a problem, throw Linux at it. That's hopefully how you should view this. And it'll become more obvious in, once you take the other classes. But anyway, so, one of the things that we will talk about today, so I said, oh, sorry, I was telling the story. So, when Unix first came out, when Dennis Ritchie and all those guys were working on Unix, it just became this like novelty. It was like, oh, okay, they created an OS, and that's interesting, but what do we do with it, right? And so as it turns out, it wasn't until the Apache web services came that people said, oh, I can use Apache on this Unix, and guess what? I have a really great web server. You guys see that? And that's really where, it kind of started, right? Once they, Apache was used, and then people could set up all these Linux servers with, websites on them, it really took off. It became like, oh yeah, let's just use, we don't have to pay anyone. We don't have to complicate things. Let's just use a Linux server with Apache. We have web services. Great. And, and so that's really how it started. And so, that's why, although we're covering this at the very end of the semester, because you guys, you're pretty good at web development and things like that, it's crucial that you understand that the keyword here is Apache, right? Apache web server, is extremely important, all right? And other operating systems, they have their own web servers, right? So Windows has its own, and that's really great. I'm not saying that it's not great, but on Linux, it's also a great advantage. Most of the time, whenever you are working, throughout the rest of the courses, whatever you're doing, you will always, let's bring up Apache, and sudo. So you guys should know by now, right? Sudo service Apache 2. All right, if you don't have it, sudo apt-get install Apache 2. If you do have it, sudo service Apache 2, and so on. Okay. All right. Did that make sense, guys? I know I'm not writing anything. I'm talking into my screen here, so but can't see your faces. But you guys get me, right?
Yeah.
Okay, great. All right. So let's move on. Let's move on to. Okay, now I have the slide. So like I said, a lot of miscellaneous topics. So I'm going to go, but I want to go through these. They're kind of important. So these are things that I picked from your managerial book that I always kind of want to touch on. I'm not going to read all these slides. Obviously, it's more. Remember, these you can read on your own and pretty much make sense of them. So you can read them, make sense of them. So I'm just going to mention, a few things. So what I have in here in these slides, let me bring it up. I have a few topics, and these are chapters from that book. So, one of them is remote access. And then one is web services, which is, the main idea. And then after that, you have software depot service, which is, software depots. I don't know if you realize, but it's basically whenever you do sudo apt-get install, you're actually connecting to a repository. Okay, that's what that is. So I'll talk a little bit about that, which is, it's like a website, right? It's like a web place where software is stored. And that's kind of for this slide. So and then the other slides will talk of a few other topics. So let me just focus on these three for now. So I'm sorry, can you guys see my slides, or are you still looking at something else?
We're looking at the blackboard.
Okay. So I need to switch. You can see my slides now, correct?
Yes.
Okay, great. So yeah, this is what I was saying. So my slides, I have remote access here. You can see there's a few topics on remote access. Then there's web services here. So you should be seeing that slide right now. And we'll talk about that in particular. I'm going to talk about LAMP, right? And LAMP is pretty important. Then after this is software depot repository, and that's software depot service. Those are repositories. That's pretty important. So let me just go through these. And I'll just get into the topics here. All right, so remote access, very crucial to everything that we're doing. I think, more so now, right? We live in the online world now. And so everyone needs to do remote access, right? Remote access. So what are some examples of remote access that you guys can give me for system administration? I just want to see where you guys are at with that. And before you answer, let me, I guess, give you the definitions. Remember that at the end of the day, this whole semester, the keyword has been service, right? Service, right? So basically, there's an operating system, which for our purposes is Unix. And then, as you know, you can write scripts on Unix. You can make those executables. You can also write C code in Unix, make those executables. At the end of the day, they become services, right? Services, right? And the whole semester, it's been about services, right? So, we talked about cron services, and we talked about DNS services, and we're going to talk about firewall services, and we talked about, SNMP and whatever, and, other things, right? So we've talked about services all semester. All right. Okay. Right. Good. So, there's a lot of services out there, right? And so today, the topic is remote access. This is a topic that I always cover. It's not like I cover it now because, we're living in this period of online. It's really that, if anything, though, everybody keeps saying that what are the things that are going to change for the future, and, more remote access. If anything, I was thinking the other day that, this what just happened just proves, if you guys were unconvinced that you were in the right major, this just proves to you that you're absolutely in the right major, right? So, all the stuff that you guys learn about, is what enables these things, right? Building Zoom, right? The thing that makes our classes possible. What is the underlying technology behind that? Remote access, right? What do we need there? Is it so much the video that's such a concern? No, it's not the video that's the important thing. The two things, what can anyone tell me what are actually, obviously we're remoted in, we're all, you guys are in your homes and, all over the place, we're all connected to some server somewhere. But what are the two underlying things that enables Zoom? Can anyone tell me? What would you say are the two underlying things that allow this to happen?
Voice over IP.
Voice over IP. Voice over IP. So you gave me that, but let's actually simplify that more into some kind of a secure tunnel. How about that?
SSH.
SSH is, again, another service that is a secure. You see that? So at the end of the day, you touched on it, right? So all of these things, SSH, SSH is nothing more than a tunnel on which you have what? Encryption, right? Cryptography. Guys?
Yes.
And the same idea with something like voice over IP, right? What is that? So it's some protocol that we take audio, and in our case, though, it's not just audio, right? There's video and everything. It's encapsulated, it is encrypted. So something that it provides a secure tunnel. You guys see that?
Mm-hmm.
Right? And examples of that, SSH, what's other examples of that?
VPN.
VPN, yeah, sure. And all of those, what's the underlying thing for those of you that took 350 already?
Encryption or?
Yes, and which one?
asymmetric?
What?
Is it asymmetric?
Is it which one? Sorry, Christine, Susanna?
Asymmetric? Like the public and private?
Yeah, SSL, right? Is that what you're trying to say, SSL?
Yes.
Oh, okay. I wasn't getting the. All right. Yes, SSL, right? So secure socket layer. So that's essential. You see, because if we weren't doing, you know, if we're not, first of all, we have to be able to do the tunnel, right? And that's a lot of network routing and everything like that that you guys learn about. And then there's the security on top of it, right? So, you know, SSH, all that needs that, VPNs, all right? So great, you see that all of this is enabled thanks to those technologies. These are things that you learn in your 350, your 270, right? Other classes, 454, you know, we'll talk a little bit about that. And this class, 372, right? Because at the end of the day, this this encryption gets done through something called OpenSSL, right? Or some kind of a protocol. There's TLS, all those things. And so all of those go into place just to create the tunnel. Once the tunnel is created, you know, once the packets know what direction to go, then you start thinking about what the payload should be, right? And the payload is the data that you're sending. So in our case, Yash said voice, but we're also sending what? What else is being sent through this remote access Zoom service? Anyone else?
Video.
Video, yeah, sure, video. Exactly. It's also sending metadata, right? Information, text. You guys type on those chats, and I get that. So it's a lot of things. It's text, multimedia, audio, plus metadata. You know, I click on something. You guys sometimes can, you know, you can raise your hand in the chat, right? So I can ask all of you to raise your hand. And so that's really, you just adjusted a setting, and I'm sure there's other things out there. We can interact somehow, that there's that element, and so on. And all of that data needs to be sent, right? So you need to find ways of representing that data. And in particular, you need to compress that data, right? You guys see that? That makes sense? What happens if you do not compress the data? Let's say you have two companies, Zoom and then WebEx. And Zoom doesn't compress the data with the right algorithms, and then WebEx does compress the data with the right algorithms. What do you think would happen? What would be the positive or the negative about that?
Jitter would be one of them.
Yeah, so poor quality, right? So one of them would have poor quality. So that's what I'm trying to make you understand, that really something like Zoom or something, you know, it's not really, you know, what makes it great is, you know, basically three things, or, you know, or four, let's say. Obviously, the people that write the software, right, to make all the interaction, all the pretty things, you know, like, you know, make it, you know, the contrast, that the color should be this and you should like it. I like the layout of Zoom. I think it was done really well. So there is that, right? So there's that human interaction, and that's important. But then at the end of the day, there's the enabling technologies, which are the compression, the secure the networking, and then, so you could call it, you know, that, and then finally the storage, right? Let's call it the servers that are running in the background. So so this would be like a nice interesting thing to look at. You guys know how, you know, what servers, because there's got to be something, right? So, you know, there's the software, there's the compression, there's the secure tunnels, but all of that has to be stored somewhere, right? Somewhere. So what do you guys think about that? What do you think might be Zoom's, or maybe you've read about this, but what do you think might be Zoom's, like, hardware operation, if you know what I mean? Like, you agree that they have servers, correct? For instance.
Yeah.
Yeah, exactly. They have databases in there, user accounts, all of that, you know. And then what kind of servers do you think they're using? Do you think they're using Windows servers, Linux servers, a combination of them? What do you guys think?
Most likely Linux.
Yeah, most likely. We don't know, but here's what you know. You know that, hey, I can do the secure, tunnel with OpenSSL. I can configure VPNs. I can do compression algorithms. Unix is very handy. So if you were building, I can write software of all kinds, not just Python, but C, other scripting languages. And so you know what? If I'm building Zoom, I should probably look into some Linux servers, right? Do you think that they have these Linux servers at some site, or do you think that they just have them in the cloud somewhere? What do you guys think?
Probably cloud.
Probably cloud. Yeah, that's a good intuition. As it turns out, it's amazing how a lot of these companies, Zoom and every other, I don't know if Zoom is yet a billion-dollar company, but probably very soon, right? If this trend continues. So, you would think that they would just have a lot of servers and they're like worrying about the hardware, but we saw in the data centers slides, you saw all those pictures, right, of servers and how they are. And sometimes it's just more efficient to have them in the cloud, right, as Josh said. So which cloud company do you think they might be using? AWS probably, right? So AWS, their business has been booming during this time, and if Zoom is doing well, definitely AWS is doing well. Not bad for a company that started at Amazon because they didn't know what to do with the servers during downtime, right? During sales in February and March. So that's not bad. But anyway, I thought, using Zoom here was a pretty good example of this. Obviously, remote access is not just about this. In particular, I'm going to look at, or we are going to look at, remote access from the system administration point of view. But I just wanted to kind of use this example because at the end of the day, it's about these factors, right? These are not the only factors, but these are the main factors that define a successful service. You have your servers running Linux, probably in the cloud. You don't even have to, you rent them then, you don't even buy them. Great thing about this is they handle a lot of like the security. You want to have a, if you remember in 350, you want to have a public key, private key, and you want to have certificate authorities. They handle that for you on the servers. So they basically do some of the sysadmin work. And then at the end of the day is about a secure tunnel, security, TSL, SSL, compression algorithms for sure. You're gonna, it doesn't matter if, Netflix is great if they can't send the movies really fast, right? So you need to have some kind of compression going on in there, and then writing some very good code. Obviously, you need that skill in there. All right, so pretty good. So now let's move on to go through some of the slides here. So we'll talk about remote access as a service. Okay, and you guys already gave you saw that what goes into building this basically, but also you saw. You already know that there are some classic examples of this, right, for sysadmin work. So a remote access service gives authorized individuals a way to access the company network from home, right? So basically that's what we're doing here, right? So we're accessing the classroom from home, except, somehow we've created another classroom virtually, right? So, a remote access service gives the unauthorized user a way to access the company network from home, customer sites, or other locations, right? So, we're all kind of, connected, around the country, literally, or even the world. So that can also be the case. So a lot of examples of this. In the early days, it was something that, This is just the sense of humor of the book. In the sense, it was something that weird technical people like Dennis Ritchie wanted so that they could do extra work from home out of normal working hours, right? Basically doing work without getting paid. All right, so you know, that has evolved, obviously. I mean, as I said, I cannot motivate this any more than our current situation motivates it. But anyway, so that's basically the definition of it, right? And then many problems, as I kind of stressed, get lumped as remote access. You know, people want to check their email, access data when they're on the road, right? So that's the justification of it. Okay, and then this is important also, you know, for nowadays, as I said, we're all remote workers, but in the past, you know, some workers would go out, there's basically like the accounting firms, for instance, KPMG and those companies, they put their own employees at someone else's site, right? And so in that situation, those people need to work remotely from there. Now, there are various differences in remote access. So for instance, you know, I know Susanna said like SSL, SSH, SSH and VPN. So this is more of a protocol, so we can leave that one out, but SSH and VPN are very good examples of this, right? So VPN is the kind of thing that when you're working remotely and you want to access the company site, right? So, you know, that's definitely a service that you're going to use. We'll cover VPNs in a lot of detail in our 454 course, so no worry there. And then SSH is more of an internal network kind of a situation, although it works perfectly well over the internet. So let me just go back to this example of Zoom, right? So Zoom has servers in the cloud, right? Servers in the cloud. And, you know, in particular, they have a web server, right? You know, basically the web server, you know, where you go to click and you download and you start the whole process. So this is running Apache on the Linux environment. But as you'll learn in the lab, in Apache, you have the var ww folder. And that's usually, you know, if you remember the Unix file system, which is, you know, we looked at a really nice lab about it. The var ww is where your web development files are located. So if a remote worker, one of you guys at home, you're working, you got to update the website. What do? You need to remote in to the web server, right? And the one way of doing it is SSH. Now there's another one. So I'll post this question to you guys. So SSH would be like if you want to be on the terminal of that machine. You know, you need to go in and do some configuration in the files, right? So you know, in your lab you could do this also. If you set up 2 VMs, you can SSH from one VM to the other VM and just do the configuration that way, and you practice. Now I ask you this question. That's one service. Now let's say this is something that I do. You guys have noticed, for instance, so I'm not Zoom by any means, but you know, you guys saw that I have that website where I post all the videos. So every day, pretty much today I'll do this. When I want to post that video, so the video I post on YouTube just because I don't want to have to deal with gigabytes of data. And so I just post it on YouTube, but then I have the link, right? And I have to add the link to that website. So what I do is I could SSH and, you know, somehow do it. But instead, what I like to do is I like to have the file. So I take a file that's in this server, right? I take a file that's in that server, and then I have it here. I bring it to my computer. So I bring the file to my computer, make the change in my favorite text editor, and then I resend the file back to the server, to the same location. So I send the file back to the same location. So can anyone tell me, what's the name of the service that I could use to do that? to send the file. So not SSH per se, but another
FTP.
FTP, SFTP, right? Who was that? Yash, was that you?
Yeah.
Okay, great. Yeah, you know, SFTP, perfect. That's yet another service in Unix, right? And it's all related to my web development, you know, kind of the thing that we're doing this week. And this is what I do. And I'm sure this is what the Zoom developers do, right? So they build yet another secure tunnel. Notice how important that is. Secure tunnels and compression. They're the you know, I would argue that Facebook, you know, Netflix, Zoom, whatever, all of these companies, all they are is secure tunnels that move content around. So, I mean, I'm sure people would disagree with me, but so anyway, so that you know, those are important services, okay? And so this enables a lot of our remote work. So you can modify your server that's in the cloud, your Unix service. You know, we're just going to agree that this is Linux. And then over here, you know, I have a Mac, you know, so I'm using my Mac, and you know, I make the changes there, and so on. All right. Great. All right, so you know, when you think about a service, right, and how to provide it, you want to provide remote access service, you should start by understanding your customer's many and varied requirements, right? So for instance, you know, right now, the university is having a really hard time thinking about this, right? Because it's been thrown at them. You know, if you guys want to have VPN access to the servers, that requires that the school should have a VPN server with thousands of licenses, right? Because you know, that's the way it works. That's how Cisco and pretty much all those companies monetize. You know, they scale up by the number of users. So you know, administration really needs to worry about this. You know, they also, you know, we know there's remote desktop and all those services, but they need to provide that background that should scale and support that really, you know, that big size of the user base, basically. All right. You should also decide with your customers what service levels the essays will provide for the various aspects of the system and document those decisions for future reference. This just refers to the fact that you want to make the service as automated as possible, because if every single one of you is having trouble connecting to the VPN services, you know, it just generates a lot of work for the system administrators to solve that, right? To solve that. And so, you know, those are all important issues. Right, and then, you know, just talks about building the service with there. Okay. Yeah, so this is obviously, at the end of the day, everyone must have access to a low-cost, convenient remote access solution. You know, and that, you know, you guys, we're using, for instance, the example of Zoom. Zoom is free for you guys. And so, you know, you can, at least for this class, I believe. And so, you know, there should be no issues there. All right, so we've talked about that. Yeah, so this just talks a little bit about making it, as I said, automating it, right? Because if it's too complex, it's going to generate too much work for the system administrator. Okay. Security, I don't think I need to mention so much of that. You know, we cover a lot of, at the end of the day, security is what here? You know, updates. We're going to talk about updates actually next week, but updates to the software. You saw, for instance, Zoom again. They now, if you started with this process, it's funny. At the beginning, there was an icon missing. The security icon was missing. It's now there, you know, because Zoom, you know, never expected to become so popular. So it wasn't very secure, actually, as it turns out. They've been updating all of that. But, you know, any remote service should have security, even though you know, we're not like, you know, I'm recording these videos and posting them online. So it's not like, I want confidentiality here, but people might use Zoom for meetings at work, you know, or you guys, maybe you celebrated a holiday over the weekend and you wanted to meet with family and you want to keep that a private affair. So in that case, security becomes very important, right? So, you know, we spend a lot of time in this course in 350, 454, talking about security, so don't worry about that. We'll cover those topics later. But you know, and these are all topics really that tie in a lot to network security, and which is remote access. But security is important. So you know, transmission of information unencrypted over the internet may also be considered publication of the information in legal terms. Think about that, which causes the company to lose intellectual property rights. Look at this. Look at this one. So that, you know, basically that's like saying that, you know, I generate these videos and I want it to have copyright over them. This is mine, and you know. Well, it just, as it turns out, if I'm sending the data unencrypted, you know, it means that I lose that right. So notice that there are implications there that are important. All right. So it's even from a intellectual property IP, you know, issues for a company that, you know, you definitely want to have security in there. You don't want to send passwords unencrypted, right? So you guys log in, I'm sure. So that needs to be in there. The encryption mechanism needs to provide access to everything that a person needs on the corporate network, be reliable, and have recently high throughput. So this is just a VPN. Recently high throughput, remember, compression, efficient algorithms. We'll talk certainly about efficient algorithms in 350, or we did already. The service also needs to cater to people who need to access the network from another company's site, such as engineers and consultants. So we already talked about that. Like if you work for KPMG and you're at that site, but then you want to go back to your company's site. All right, and so on. So security certainly is central to remote access, and I believe that you guys understand that. And you know that that is enabled mainly through crypto. And that's why cryptography is such an amazing, amazing topic. All right. So the security, the usual method involves building an encrypted channel or tunnel between the person's machine and the company's firewall, or, you know, from point A to point B, crossing the customer's firewall and the internet. So basically, whenever I talk about things like, whenever I talk about things like this, I always say an encrypted tunnel. That's the key word there. Encrypted tunnel. Remember that, you know, I should stress, we're not building a tunnel, right? There's no physical line. It's all across the internet, and all we do is an encrypted tunnel means I have a TCP packet, but then I have a UDP channel. Right? And so what's going to happen is my TCP packets go into the software here, and they come out as TCP packets encapsulated in a UDP packet, where this one is now encrypted. Right? So that's basically what that means. So it's encapsulation of packets as encrypted packets. Any questions so far, guys? Any questions? Okay, it seems like there are no questions. All right. All right, then, you know, to conclude remote access, I think we've spent quite a bit of time. Sorry, yeah, go ahead. Did you have a question, Alicia?
No, my cat jumped on the keyboard.
Okay. All right, no problem there. All right, so yeah, so to kind of wrap up remote access then, all right, so now to kind of wrap up remote access, as you know, policies, there's always a policy for everything in an organization. A policy, you know, is basically a document written in general words, not in technical words. So you can say we need to have a remote access solution of some kind, maybe VPN, and that's as far as you can go. But you have a lot of these in place. So before starting to provide remote access service, the company must define policies for remote access. So I'm pretty sure right now, the university, for instance, has all these challenges with remote access. I'm pretty sure we don't have a policy for Zoom or anything like that, but eventually information services will create even a policy that governs this whole Zoom thing, because there might be problems, you know, and so on. So it gives a little bit more guidance. And this is what this is saying. So a policy should define acceptable use of the service, security policies surrounding the service. So, you know, if I was using, for instance, not Zoom, but some other service, and then they would tell me, hey, no, but your service is not encrypted, so you can't use it, you know, something like that. And then the responsibility. So you all have responsibilities for using Zoom. You guys have heard of that thing, Zoom booming, right? Have you guys heard of that? Okay, so maybe you haven't. So it's basically that you have people that would, you know, let's say that I had gone on my website and I had put the ID and the password. I almost did that. I thought, okay, I should put it here so it's convenient. Well, the problem with that is anyone could have found that on the internet, and then they would have Zoom boomed, or whatever the word is, us, which means basically they would have joined our session and then maybe played really loud noise or things like that to try to disrupt our sessions. Believe it or not, that has been happening. And so, so basically, you know, there's responsibilities, right, attached to people connecting. And so, you know, the policy should cover. So the policy should tell us you should never post your ID and your password on your website. That's why it's posted only on Blackboard, let's say. So only students, you know, anyone, you know, and then also you guys should not like put it on your website, right? Or Instagram or something, right? And so that's basically the idea. Okay, does that make sense, guys?
Yes.
Yeah, okay, great. All right, thanks, Yash. All right, so very good, very good. And then this is the same thing, so definition of service levels. Again, how you're gonna provide services. Just keep in mind what's important here is to consult your customers, right? You know, at the end of the day, you can't make a policy that doesn't work for me, right? You know, you can just tell me you can't use Zoom and then figure it out how you're gonna teach class or something, or how you're gonna manage the web server if I can't use FTP. So there's gotta be some things. Okay. You know, remote access obviously can be a sensitive area because failures are discovered by people who want to do some work and aren't able to do anything until the service is restored. So this is, you know, problematic. Let's say that, you know, for instance, you guys, you need to do your homework and get into the school computers. Well, if the VPN doesn't work, you know, how are you expected to do your work? You see that? And so that can result in you guys being very frustrated. All right, so remote access policies definitely need to address, excuse me, all of this. If the service levels are clearly defined, communicated, and understood before problems arise, the customer should know what to expect for an estimated time of repair and so on, right? Centralization, so remote access is an area that benefits from centralization. Centralization is actually a topic that is in the book, in the managerial book, it's actually its own topic. Now, what I can say about centralization, I think our scheme is not centralized. Like I figured out how to use Zoom and, you know, and I know pretty much a lot of people did the same. It's not like the university is using it. WebEx is more of a centralized approach. Have any of you guys used WebEx?
I do for other classes.
For other classes, right? And what do you do there? Do you have to go through like a boiler key maybe or something?
No, it's just invite.
Okay, so it's just a link.
Yes.
But possibly if, and I'm not like criticizing WebEx, I'm not saying that at all. So I honestly use Zoom, like I flipped a coin and this is the one I use. So, but what I want to say is, I'm just using the example with this Zoom, for instance, I have full control. Centralization is, let's imagine that with WebEx, I would have to use the boiler key. So you can see that's more centralized. And that, the problem with that is, okay, what if I want to use, I can't find my boiler key for whatever reason. I'm in trouble, right? The model of being centralized cost me that convenience. And so there is that issue. So let's think about this from a security standpoint. The authentication component of the remote access server must be centralized to ensure proper auditing and access control. You see that? So that's what I was saying. So by having boiler key, that is, they have proper auditing and access control. Whereas this model that I'm using of Zoom is completely independent of the university. And so they don't have proper auditing or access control, right? It's not, one is not better than the other, bad or wrong. It's just an approach that you take, right? Centralization or decentralization. From a cost standpoint, new technologies are emerging all the time, e.g. Zoom, and the research costs for how best to implement and support each new technology are high, and so should not be duplicated across the company. So that's, again, the idea that we all spend all this time setting up, learning about this new tool instead of centralizing it somehow. And then obviously when you centralize, you have economies of scale. So for instance, the example of that is that all of us individually pay for this service, Zoom, but if the university negotiated a contract for all of us, I'm sure the cost would be smaller. All right, and so that's a perfect example of that, I think, my opinion. Please stop me at any time if you have any questions, or you want to make a comment. Feel free to make a comment, please. Okay. So let's move on. Authentication, I think we pretty much touched on this. Obviously, it's remote access, it's important. So the authentication and authorization system is one component that always should be built and maintained in-house, even if everything else is outsourced, right? So that's important, right? So, right now, as I said here, the way that we're doing this, actually, that I'm sort of achieving this goal is through Blackboard. So I've only given this password to students that are on Blackboard. So if you think about it, you guys are, assuming you will not share the login with anyone else, you guys are being authenticated by the fact that you log into Blackboard and then you get authorized from there to use it. You see that? Okay, and that way you're all using the same authentication database to reduce administrative overhead and the chances that someone would be overlooked. So none of you will be overlooked because you all have access to Blackboard. I sent an email, and that, during this time, you're all expected to at least check your email, right? And so, from there, to log into Blackboard, follow the instructions, follow the credentials, you get authenticated. But at the end of the day, with remote access is pretty important to authenticate things, and so on. Okay, all right, so that's pretty much it. All right, so that's remote access. I think, hopefully all of that made sense. Kind of in summary, I want to remind you that a lot of things can be remote access, right? VPN, classic example. I won't cover a lot of VPN. I'll probably cover some VPN next week because I have to talk about security in Unix. But at the end of the day, remember, we cover this quite extensively in 454. So especially once we have the classroom back, we have even more opportunity to do things with hardware. But we do cover this software. And then, SSH, but also secure FTP. And then it's also for Windows, remote desktop. And then there's third-party things and so on, right? So there's quite a lot of things related to this, all right? All right, are there any questions before we move on? So I'm done with remote access, and now I'm gonna move on to web services. Are there any questions before I continue?
Nope.
Okay, great.
Nope.
In particular, when I talk about when people talk about web services as it relates to Linux and Unix, this is the keyword, okay? Apache Web Services. So Apache is the daemon or the web service, whatever you want to call it, that is the keyword. It's central to web services. So you guys in your lab this week, you will be working on a web service, right? That shows SNMP content. If you don't get this right, it's not going to work. And this will be the most challenging, thing that you will do, okay? So this will be the most challenging thing that you will do in that lab, okay? It'll be the most challenging thing you will do in the lab, right? So just be aware of that. All right. So web services, the first thing, again, look, that's one of the key words, right, in this semester, services. So we looked at services for this, services for that. Now we're going to look at services for, web services. That's the daemon Apache. At the end of the day, it's just some code that people wrote. It is tied to a port number. What port number are web services tied to in Unix and in general, really? What's the port number? What's the port number of Apache?
443.
Well, actually, there's port 80.
Right. And then 443.
Yeah. 443 is which one?
The secure HTTPS.
The secure one. Perfect. The encrypted one, right? Exactly. So it is the encrypted one, because encryption, once again, web services are remote again, and so you need that. But also port 80, the clear text one. Okay, so managing web systems has become such a large and important part of system administration. All right, so it's important to system administration that specific techniques and specialties have developed outside of simply loading Apache or IIS, the Windows version, and then providing the content, right? So there's issues around the web services, right? And that's why I want to stress that in this lab you guys are doing two things. In this lab, you're generating the content, and that's SNMP content. And pretty much all of that I gave to you. I've given you the scripts for that. But then the other challenge is the Apache itself. You need to configure this, right? And it's not, you'll have to basically pay attention. As I said, the tutorial is meant in such a way that not everything is solved. There's a few things that you will have to solve by yourselves, kind of figure it out a little bit, okay? So a website, this I don't really need to specify. We all know what that is. So a website is a way of presenting information and applications to users. You guys know a lot about the client-server architecture. Remember, the client is your desktop, computer, your Mac, your Linux box, and then the server is the thing that is running the Apache service. So whatever is running Apache in Linux, that's your server. So then you access it through the browser, and then you get, it delivers pages, and then you guys know tons of, you're using HTML, CSS, and also JavaScript, right? JavaScript, jQuery. And then sometimes on the server side, you have something called PHP. How many of you have already taken 362? Any of you taken 362 already?
I'm taking it right now.
You're taking it right now. There you go. So you know what I'm. So can I ask you this question? Are you using LAMP?
Yes.
Are you using
I'm
LAMP
using,
in
actually,
Linux,
we're
or are you
using
using like a
XAMPP.
Windows LAMP?
Yeah, we're using XAMPP.
Okay. In what operating system?
Let me see. It's like I have it installed in my Windows, but it's we're installing it initially on Linux.
Okay. Yeah, right. So at the end of the day, LAMP is such a, well, I'll talk a little bit about LAMP. LAMP is now made in such a way that even though you might learn it in Windows, it works the same way in Linux. So it's not a problem. But yeah, you know, that's great. So there's all these languages, and, you know, that's basically, it means it's a lot of things that you need on your server, right? And so it's really, so the point here that these slides are not about, you know, web development, like, you know, I'm going to write my HTML and so on. They're more about the configuration of getting everything ready for your web server to work, if that makes sense. All right, great, great. So a web server, that's really the key thing, right? A web server, in this case, a Unix machine running, Apache is really what does all the work. Okay, it's really what's going to do all the work. Okay. All right, so web server receives the HTTP request. Oops, sorry. Receives all the HTTP requests. As you know, there's Apache and Microsoft. Then it sends static files, an HTML file. You basically all of this you've learned in 362. And you know that, for instance, 362 in 110 you learn to do static, and now basically in 362 you're learning to do everything on the server side and dynamic. Right? So you have databases, database queries in SQL. You have jQuery that does everything, and you can actually change the text boxes and the buttons right there on the fly in real time with dynamic jQuery and so on. That's the whole point of it. All right, good. The Webmaster Role, so that, you know, that's really the Webmaster is like the system administrator here, is the person who manages the content of a website, you know, responsible for setting the website policy. Again, that word policy comes back. You know, then you have web system administrators who set up the server, you know, software and so on, right? So you can see that usually, you know, you're not gonna, unless you're a really large company, you're not gonna have a webmaster and then a web system administrator. It'd probably be the same person. Usually though, there is a difference between like the IT person that can set up LAMP versus the web developer. So those are sometimes different skill sets, but they can be the same set of skills as well. And then, you know, as you know, the system administrator maintains the technical machinery, physical and virtual. Nowadays, a lot of this is virtual with AWS. Okay, and then, okay, and so on. Okay, and I just said that. So again, you go back to this idea of service level agreements. So service level agreements. So like any other service, a web service needs a policy to ensure compliance, right? And so you know, that's the same thing. You have some policy that governs the setting up of a web service, content that you're going to show, and so on. Now, what's important here is architectures, and that can sometimes be a challenge, right? So whenever you're establishing a web service, you might have different architectures. Different types of content require different serving infrastructure. And this is actually very relevant as you're learning that in 362, right? You're learning that, for instance, you might have SQL. You're using MySQL, and then you have where you're running Apache, and so on, right? So these actually can be two separate servers. They don't necessarily have to be the same one. Even though in your lab you're probably doing one single server, they can actually be two separate ones. And so you just the infrastructure is built in such a way that you can have multiple, right? And so that's really what this is getting at. That setting up a web service can actually involve multiple servers. So a single web server serving an unchanging document has different needs from a page serving dynamic services, right? Like having, as I said, a MySQL and then the Apache, and you have that kind of separated out. And then there's also the difference between web servers that will be accessible from the internet rather than only within the organization. So they have different security needs, right? They have different security needs because let's say that you have an intranet for the organization. Well, you don't have to provide that many security because you can always just connect via VPN to that site and then access the server that way. But if you're only accessing things through the internet, then that's entirely different. So accessing something from the internet means that you have to have more security there. And so that's kind of the issue that's being addressed there. All right, so here I have a diagram, an example of how to, if we were building this physical network, right? So, how we could separate out a web server, right? So in a 3-tier kind of thing. So you can see here, this is the internal network, right? So obviously there's a firewall here. This firewall is very restrictive. It basically doesn't like to allow anything from the outside coming in. Now, then this is the internet. So this is very untrusted, right? You have, here you have both remote workers. You have both remote workers, but you also have over here hackers. Right, and so, you gotta watch out for that. This is just a router. And then here you could have like multiple firewalls with access control lists, or they could be firewalls themselves. So basically the idea is that as you go in that direction, it's starting to become more trusted, right? And it becomes more trusted because you have more restrictions here. So basically you have ACLs and then ACLs and then ACLs, which are access control lists. And what that means is that as you start going in that direction, in this direction, it starts to become more restricted. So here you might allow, you allow port 80 and port 22 and 443 and, so on. As you start going in here, maybe now you only allow 443. You see that? And so it becomes a little bit more restricted in the services that you provide. You can also see that here we're separating out the database. So for instance, the database, it's its own server and an application server. So maybe here you have some pages, right? Some content. And then this would be the first thing a remote worker, when they want to access, they'll go there first. But then this one will definitely need to query the database. Just notice that before they get to the database, they have to go through all these firewalls. So they have, that packet needs to be basically filtered by this one and this one, right? So they'll tell you if they're going to give you access or not. Does this make sense, guys?
Yeah.
Okay, great. So that's basically what that means. So remember, we're looking at this from the system administrator point of view, the person that has to enable this. So, whether you're doing this in the cloud or not, you would rent 2 instances of servers, or you're building your own physical network. Well, then you have to build, you might want to build a structure like this. In particular, if you're doing e-commerce, kind of very secure thing. Obviously, though, all of this could be in just one single server as well. Okay. All right. Okay, so let's keep going. So we've talked about static web servers, so that's, you know, pretty simple. It only serves simple documents. They're not dynamic, basically. You know, normal documents, web pages, etc. And so, you know, not so much there. Then we have the dynamic database-driven websites. Those are the ones that, you know, will query MySQL, and I already pretty much talked about it. Okay, so they have the database in another server that can be accessed. Okay. Multimedia servers, you might have those where, you know, YouTube, right? Netflix, they have a lot of videos and things like that. So multimedia server is primarily a web server that has content that includes videos and audios. So they have to be, they have things like they have to be very large. So that's, you know, the example that I gave you guys. My website, for instance, where I have the videos, it uses a multimedia server. You know, because I have all those videos, I did not want to store them and deal with them. You know, I'm pretty sure Amazon has ways that they receive a video and compress it, and then they decompress it, and, you know, efficient ways of handling it. So my solution, and I think pretty much everyone does this nowadays, is that they just, any content that, you know, it's, you know, unless they want it to be paid, right, they post it on YouTube. Netflix, on the other hand, they have another scheme, but they have to be very good at dealing with multimedia. Because multimedia files are very large, sometimes are accessed through some type of special client or browser to comply with digital rights management, right? So like Netflix has that. So when serving media files, the underlying data storage and network bandwidth have to be very powerful, right? So these become very important. So they have to provide streaming media support, right? So you have to account for that. Okay, and so that creates new challenges. Okay. Right, and then this just talks about, so if it's streaming media, you know, on the receiving end, you have to have a special purpose application that has capabilities to buffer data for a few seconds to compensate for delays, right? So, you know, I don't know if you guys, but you probably experience this right now. There's so much demand in the internet, right? That you literally now, you see a little lag, right? You know, maybe not in Netflix. I think I've actually seen it in Netflix, but you may not see it but in other ones, like other services, you might see this a lot. Okay, I don't know if you guys heard a story that in Europe, they had to actually make all videos from HD to SD just because, you know, HD is obviously more data and it was gonna break the internet over there. So anyway, so those are important issues, you know, as you're dealing with things. So, you know, certainly considerations for multimedia are significant with terms to data storage and bandwidth. Are there any questions about any of that, guys? No?
No.
Okay, good. So everything's pretty clear, I think. All right, so the main topic when you're talking about things like web development, etc., is LAMP, right? So LAMP, it's an industry term. It basically means for technologies, usually, okay? It's a combination of technologies or platforms that are common enough to have a name for web development. So like I used this when I asked Yash, you know, hey Yash, are you using LAMP? And he pretty much said, yes, so he understands what I'm talking about immediately. So it's basically the OS, the web server that you're using, the database, and then the programming language. So in the classic example of 362, you know, you use Linux, Apache, MySQL, and PHP, all right? And so that's what LAMP stands for. So it stands for Linux, Apache, MySQL, and PHP. And PHP is just a server-side programming language that you're gonna learn about when you guys take 362. Okay. All right, and that's pretty much what that is. So usually you just have to install it. So for this week's lab, you only have to install. These two, okay? And then you'll be using Python actually. So I'll show you guys a little trick of how you could use Python to develop web content. At the end of the day, you're still developing HTML and CSS. And that's really what PHP does. PHP is just a script. When you run it, PHP does the same. It generates HTML. So at the end of the day, the output of both Python and PHP is still an HTML, CSS with JavaScript, because the content of the PHP script or the Python script does not show at all. It's only meant to be there to run and generate some things. Okay. So the web team, as you know, I won't spend any time on this. It's just, the people that work on the websites. I think at this point we've talked about this quite a bit. Some recommendations about building a manageable web server. So an SA will be asked to set this up, so that that makes a lot of sense from scratch without being given any specific information. So some of the questions that you probably want to ask whenever you're asked to build something like this: will the web server be used for internal customers only or access to the internet? Right? So that speaks to security. How much storage is needed? You have to create accounts for this web server. What are the uptime requirements of the server, right? So, how often can it go down? Does it need to be up all the time? What is the expected traffic, right? So this is usually something that people don't know much about, right? So, what happens when you scale up? Is it gonna break? Is it gonna slow down? How will it grow over time? You have to think about that. All right, does it hold a specific software? What is the content basically, and so on. Right, so these are some of the questions that you need to address when you're looking at that. All right, and that's basically Apache Web Services. So I will talk about the lab on Wednesday. Okay, so on Wednesday we'll go over the lab. Today I want to finish these slides, so I just have this one: Software Depot Service. Software Depot Service. All right, and that's an important one. So it's basically, Software Depot Service. So as you know, installing software is a huge responsibility, because if you work for a company and you want to install a software, first of all, they don't let you, right, install software. So my work computer has a password. Every time I want to change something in the computer administratively, I have to request a temporary password. It's only for like a day. And so you have those issues, right, of your software gets changed by other people, and some of it is, the security of it. They want to feel that they have control because they want to decide what software is allowed. So Software Depot services are useful for this. The idea is, for instance, replicating these tools to dozens, hundreds, or thousands of machines is impossible without automation. Right? So as you know, the common theme here is automation. So instead of having tons of people asking, hey, can you install this program? Hey, can you install that program? Sometimes a good solution is you are allowed to install your own software if that software only comes from this specific repository. Do you see that, guys? So that's the solution to that. So that's a very common solution in the past, right? There's a repository and you go there all the time. So if a software depot is not provided, non-technical customers will simply lack the tools to reach their full productivity, right? They won't be able to install the software. And then on the other hand, technical customers will install these tools themselves, most likely duplicating the work of others doing the same. So I'm pretty sure you guys, your IT students, you're very savvy at installing things. right? So you're on the side that you probably want to be able to do this on your own. Either ways, customers will, might lose productivity though if there's no approved set of tools. So for instance, let's say that I didn't know anything about remote teaching, right? And so, which I didn't. But so what do I know? Well, I can start searching the internet and find some third-party solution, or maybe the school has already a repository, and on there's Zoom, and then there's WebEx, right? And so I can just choose one of these two, right? And I just click on it basically, and they're already like researched everything. They're already categorized as online teaching or online meetings or something like that. All right, and so that's the idea with a software depot or repository. Now, I don't know if now how does this relate to Unix? So you might say, well, that's not relevant to Unix. Well, as it turns out, it is. Can anyone tell me, does Unix have a repository? And if so, how do we access it? So that's a good exam type question right there. How do we access, does Linux have repositories of software for us to install on our computer? And if so, what's the command that allows us to access those repositories? What do you guys think? Anyone there?
It does have repository. Yeah.
How do you access it? Do you know?
I know how I've done it, but I just don't know if that's what it's actually called.
Well, no, you've done it actually. Every time you know when you do it, when you do sudo apt-get install.
Right. Yeah. See.
Yeah. So all of you have accessed this repository. What sudo apt-get install does is that somewhere in the Linux, there's a little file. And that little file has these IP addresses of 2 to 3 servers on the web. And these are the Linux repositories. So basically, whenever you do this command for some software, the program actually looks at that link and goes to those servers and it downloads your software. Does that make sense? So that's exactly how Unix controls this idea of controlling the software. So they provide with sudo apt-get not only software that is compatible and stable, but it's also software that they know is secure. Because it's not like you can just go and download something that is going to corrupt your system, right? Or do like malware or something like that. This is actually really great. You can go download it and so on. Does that make sense, guys? That's an important concept, and I hope you understand. Okay, so it's basically, it's a software depot. A software depot is a customer service that finds, installs, and maintains a library of software. So Unix itself provides this for you with sudo apt-get, and then otherwise, you use this, I think, with Microsoft. You guys have an account where you can download some software and things like that. So, same idea, just, different implementations of it. And then the rest, a depot saves people from searching for the software on the internet. I don't know if you guys do this. I think when I was a student, I would go to the repository. So if I had a Windows system, I would go to the repository and literally look at all the software that they had. And I would download anything that sounded great, even though I would probably never use it. Just, it's there, right? So why not have it? So anyway, that's the idea. It's sometimes the advantages of that is that it's also free, or let's not say free, but it's paid. As you pay for school, the software licenses are provided for you. I think like VMware is probably a good example of that. They provide it somehow. All right, and so that's really the idea with software depots. And I'll stress, in Unix, it's called a repository. And then, yeah, this is pretty obvious. You can just read through that slide. Again, there's a policy there because it has to be secure, right? So that you only download software that is approved. And then here's some of the questions. You know, handling upgrades. What OSs are supported? Do they only have software for Windows, Mac, Linux, etc.? How to request the software and so on. So you can see with Linux is pretty handy, just sudo apt-get install. Another repository I would say is Anaconda. For those of you that started using Anaconda, you can actually install software from that, and that's another way of downloading secure software in a very convenient way. So again, policies. All right, and that's it. So we went through these slides. That's really great. And now we can just focus on the lab. I will talk more about the lab on Wednesday. I will go over the topic, and just, you know, you can work on your lab. All right, so this concludes our class for today. Are there any questions before we close the meeting? No questions, guys?
I don't have one.
Okay. All right, so if there are no questions, if you have questions later, just email me. Otherwise, we're going to stop here for today, and I'll see you guys on Wednesday. Thank you.